Okay, so on example 1, today is the first day that we have variables on both sides. So when we look at our yellow sheet, we have our railroad tracks to separate the sides. It says combine any like terms on the same side. Well, this doesn't have any like terms on this side, neither does this. So we go on to step 2. Step 2 says move the variables to one side and the constants to the other. Well, I already have all my constants together, so I need to move my variables. Make sure when you are moving variables, most people tend to think, oh, there's a coefficient there, so I multiply and divide. No, moving, whether it's variables or constants, anytime you go across the tracks, that is going to be addition or subtraction. So I'm going to move the 4D, because if I move the 5D over, there would be nothing left on this side. To move it, I do the opposite. Since it was a plus 4D, I subtract 4D. These cancel out, so on the left side I have 8. On the right side, 5D minus 4D is 1D. We know that 1D is really just D, but to see what we would normally do to solve the rest of this, anytime there's a coefficient, now it's step 3. Get rid of the coefficient by multiplying or dividing. This one was really multiplying in between, so the opposite is divide. You divide by 1 on both sides. 8 divided by 1 is 8. You can check your answer by typing that in on both sides. So on this side, I would type 8 plus 4 times, and my answer for D is 8. When I do, I get 40, so I wrote that up above. On this side, I do 5 times 8. And if you get the same number, then we know we have the correct answer. Okay, so you guys were working on your got it. Put your pencil down if you are done with your got it. That means you've solved it and you've checked it. That tells me I can be going over it then. So I'll give you, some of you are still working, maybe 45 more seconds. Okay, looks like most of you are done. So I'm going to highlight my variables in yellow, my constants in green, put in the railroad tracks. Hallie, do we have any like terms on the same side? No. So we go to step 2, where I have to move the variables. On this one, Valeria, which variable am I going to move? Good, the 5A. How would I move that across? So subtract, great. So I'm going to do minus 5A, minus 5A. When I do that, Braden, 8A minus 5A is 3A. On the right side, Raylan, what do I have left? 21. At this point, I have all my variables on one side, all my constants on the other. So we're done with step 2. Now it's step 3. Get rid of that coefficient. How would I get rid of the coefficient? Jackson.
Divide by 3.
Good. Divide by 3 on both sides. And I end up getting A is equal to 7. If I want to check this, how would I type it into the left side? Aiden. This one. 8 times 7. Very good. So that is 56. On the other side, how would I type it in? Mari Carmen.
21
Good. And I actually like to go left to right. So I'm going to go, it's going to come out to be the same thing. But 5 times 7 plus 21. And I still get 56. So I know my answer is correct on that one. Good. Are there any questions on that one? No? Okay. On the next one, let's go ahead and highlight. So again, I'm going to do my constants in green. So James A., what am I going to highlight in green? Very good using the signs with it. Nice job. So that means my 6N and my 4N are going to be in the same color. On this one, Kaylin, do I have any like terms on the same side? Yes, I do. What are they? Very good. -6 and +1. So I want to combine these right away. Okay? I underlined those so that I could see what part I am combining. The rest of it, I'm going to leave exactly the same. So any part that I didn't underline, I'm just going to write it straight down. 6n minus 1 equals 4n. And then -6 plus 1, when I go to do this, guys, I am not moving it across the railroad track. So I'm not doing the opposite. I always have somebody that thinks I do the opposite here. No, I just combine them. -6 plus 1 is anyone? -5. So I'm going to write -5. At this point, I'm going to highlight again, just because it really helps me when we have 4 different terms to see what terms go together. Okay? From here, which variable should I move first? And if you look at step 2, it does say move the variables and the constants. I always move the variables first. Sometimes, if the answer is 0 at the end, it trips people up if you move your constants first and then have to move your variables at the end. So I always suggest to do the variables first. Which one should we move, 4n or 6n? Evelyn? 4n. Anybody think 6n? Okay, I had at least one person. Anybody think it doesn't matter? You could do it either way? Yeah, very good. It doesn't matter. So on this one, since Evelyn said 4n, we'll do it that way. So I'm going to do what, Evelyn, to move it to the other side? -4n. Good, -4n. So 6n minus 4n, Haley, is? We have 6 n's, we take away 4, 2n, very good. Bring down whatever's left, so 2n minus 1, and on the other side I have a -5 left. At this point, you could highlight again if you want, but a lot of you are really good at two-step equations at this point. You can recognize we have variables, we have constants, and what needs to move. Chelsea, what do I need to move next? But what part of that? But do I have all of my variables on one side and all of my constants on the other? No. What do I need to move? Very good. How do I do it? Awesome. Nice job. Add 1 to both sides. Very good. Okay. When I do that, on the left side I have 2n, and on the right side, -5 plus 1 is anyone? -4. Okay. At this point, now I have all my variables on one side, all my constants on the other. At this point, James, what would I do to solve? Divide by 2 on both sides. So I end up with n is equal to anyone? -2. We want to check this. How would I type it in for the left side? Go ahead.
Did you put on me?
Yep.
6 times -2.
Very good. What do we get when I type that in? Anybody? -13. Okay. Alexa, can you tell me how I would type in the other side?
1 plus...
Start left to right.
Yeah. 4 times -2, subtract by 6, add 1.
Very good. And I still get my -13, so I know my answer is correct. Okay. I want you to try Got It B right now. So highlight first, then move our variables, move our constants, solve, and I do want you to actually check your answer. Remember, if you have it done, actually type your answer in and see if you get the same number on both sides. So I should actually see the number up at the top of what you are getting. Okay, I see a lot of you struggling on this one, so we're going to kind of go slowly through this one together. Okay, so highlighting, I'm going to highlight my constants in green. I'm going to highlight my variables in yellow. And I'm going to do my railroad tracks. So if I'm using my yellow paper to help me, okay, I think a lot of you keep forgetting that it's here to help. So I've done the railroad tracks. I do not see any like terms on the same side. This one has yellow and green, this one has yellow and green. There's no colors on the same side like this one had. Okay? So then I can move to step 2. Notice, it says move the variables first. So I want to move my variables. You have 2 options. You can move the 3x or you can move the 8x. Which one do you want me to move? 3x? Okay, so I'm going to do the 3x on this one, and then on a separate piece of paper in a minute, I'm going to do the 8x first. That way you can see both ways. Okay, so if I'm going to move the 3x, this is really a positive 3x, so the opposite would be to subtract. So if I subtract 3x, now, guys, you are going to subtract that from the like term on the other side. That's part of where the highlighters really help out. So if you're doing this under the yellow here, it should be under the yellow on the other side. Okay? You can't take it away from over here because those were not like terms. So when you do this, I would cross off what's canceling. That gives you a good visual of what's left. I have on this side, -7. On the other side, 8x minus 3x is anyone? Anyone? 5x, and I haven't done anything with the plus 23, so I can bring that right down. If you need to, at this point, you would highlight again. You don't have to. I'm fine if you're good without highlighting at that point. I need my green to the same side, so I'm going to move this across, so I have to do the opposite. The opposite would be minus 23. When I do that, -7 minus 23 would be -30, and this side I have 5x left. Now that I have all my variables on one side, all of my constants on the other, now I'm to step 3, get rid of the coefficient by multiplying and dividing. Since this was multiplication, the opposite is divide by 5 on both sides. I end up with x is equal to -6. Did any of you check it by plugging it back in? What did we get on both sides for plugging it back in? Anybody?
-25.
Very good. -25 should have been what you got if you plugged it in on both sides. Okay? If you did it the other way and you moved the 8x, this is what it would look like instead. Okay? So either way works. If you moved this one instead, it would have been -8x. Minus 8x. From there, 3 minus 8 is -5x. I'd bring down my -7, and I'd bring down my 23. At this point, I need my constants on the same side. So my opposite is add 7. On this side, I have left -5x. On the other side, I have left 30. From there, I divide by -5 on both sides. When I do that, I get x is equal to -6. So notice, I get the same answer either way. Basically, It's just that these end up on the opposite side. Since 5 was on the right, and here it was on the left, it's the opposite sign, so it was negative. Since negative 30 was on the left, and then it ended up on the right, it's the opposite. Since they both end up being the opposite of each other, when you solve, you still get the same answer, no matter what, as long as you are doing your math correct. It does not matter which variable you move first. Okay? Any questions on that one? Okay, the story problems, and I promise the story problems are not that bad on today, okay? The equations are decent to write. So it says, Green's gym charges a one-time fee of $50 plus a $30 fee per session for a personal trainer. A new fitness center charges a yearly fee of $250 plus $10 for each session with a trainer. For how many sessions is the cost of the two plans the same? Well, it was asking us for how many, what are we looking for? Sessions. So we're going to use what variable? S. S equals sessions. The other thing is they want to know when the plans are the same. What symbol do we use in math class to mean the same? Equal. So I'm saying, okay, one gym is going to be on the other side, and the other gym should be equal to it. Well, if it told us, James A., that Green's gym is going to charge us $50 plus $30 per session, what would that look like? You're overthinking it. $50 plus $30 per session. How would I write that out? Nope, it says $50 plus $30 per session. I'm not asking you to solve. I'm asking how do I write that from words into letters and variables and symbols. Okay. Is this 50S? Is this 30S?
Oh, yes.
Okay, so tell me how to write it. 50 plus 30S. Exactly. $50 plus $30 per session. The other side is going to be the other fitness center, and that's $250 plus $10 per session. Jackson, how do I write that?
150 plus 10.
Very good. Now we highlight. Okay, I put my railroad tracks in. Which set of variables, Raylan, do you want to move first, the 30S or the 10S? Okay, so how would I move it? Very good, minus 10S on both sides. When I do that, I haven't touched the 50 yet, so I just bring that straight down. Hallie, 30S minus 10S is?
20S
Good. Is it positive or negative?
is a negative.
So 30 minus 10 is negative 20?
Oh, I meant it's a positive.
It's a positive. Positive 20S. On the other side, all I have left is 250. Now, I have one set of variables, and again, some of you, it really helps with the highlighting, so I'm just going to highlight again. You don't have to. I have to move my constants to the same side. Aubrey, how am I going to move my constant? Very good. Minus 50, and you said on both sides. That is perfect. So I have 20S is equal to, well, 250 minus 50 is? Anyone? 250 minus 50 is? 200. Very good. How would I solve from here, Evelyn?
Divide by 20. Divide both by 10.
And I get S is equal to?
10.
10. Now, I need a sentence. If you look back at this, it says, for how many sessions is the cost of the two plans the same? Well, at how many? How many? 10. At 10 sessions, the cost will be the same. Okay, at 10 sessions, the cost will be the same. We will probably be working up into the bell, just letting you know, okay? So it says, Easy Car Rental charges $40 a day plus 25 cents per mile. Ace Rent-A-Car charges $25 a day plus 45 cents per mile. What number of miles results in the same cost for one day? What were we looking for in this one? The number of, so let's use M equals miles. Now, I want you to try to write your equation and then pack up. Write the equation and pack up. Easy Car Rental charges $40 a day plus 25 cents per mile. Ace Rent-A-Car charges $25 a day plus 45 cents per mile. When will they cost the same? Okay, just write the equation and then pack up. We will finish that in lab. Okay, so on this one, anybody think they know what the equation should look like? Let's see. Sander, go ahead.
40. Can we put the dollar sign?
You don't need to put any signs in it, okay? Sometimes it confuses people, so I say don't, okay?
0.25 m equals 25 plus 0.45 m.
Perfect. Nice job. Okay, so we want them to be equal to each other because we want the cost to be the same. All right, so on the first one, it was $40 a day plus 25 cents per mile. 40 plus my 25 cents per mile. The other one was $25 a day plus the 45 cents per mile. So perfect, that looks great. From there, I'm going to highlight and railroad tracks, and we will solve this one together. So I want to move my variable first. Which one do we want to move? Josiah. Okay, and how am I going to move that? Very good. And remember, guys, if you're taking it away from the yellow, make sure you're writing it below the yellow on both sides. So I'm subtracting 0.25. Some of you that have not the best handwriting get a little bit disorganized as you are doing this. If that is you, and you prefer to put all of your work on notebook paper, I am totally fine with that. You can always put your work on notebook paper, and then you can use the lines to kind of help you stay organized. That is totally fine. Okay? So from here, these cancel out. So on the left-hand side, Ella, what do I have left? 40. On the right-hand side, I haven't touched my 25, so that stays. And then 0.45 minus 0.25 is anyone? $4,500 minus 2,500 is 0.2 or 2/10. It's a positive 2/10 m. Okay. Jacob, what do I have to do next?
Subtract 25.
Subtract 25 on both sides. So 40 minus 25 is anyone? 15. On this side, I still have my 0.2 m. Now that I have all my variables on one side, all of my constants on the other, so I've moved all the green to one side, I moved all the yellow to the other side. Now I'm on step 3, solve by getting rid of the coefficients. So what would I need to do, Haley, here? How would I get rid of my coefficient?
Divide.
Very good. Divide by 0.2 on both sides. And when I do that, what do you end up getting as your answer? 70, or now that I give you the answer, m is equal to 70. It is 70, right? Oh, is it 75? I was remembering wrong from doing this in the past. 75. Okay. So that would look like this. 15 divided by 0.2, and that's where we're getting our 75 from. Okay? Now you need a good sentence. What would be a good sentence for this? Remember, the question says, what number of miles results in the same cost for one day? Evelyn, what you got?
75 miles results in the cost of one.
Say it again.
75 miles will result in the same cost for one day.
Good. 75 miles will result in the same cost for one day. Good. Okay. Are there any questions about this? Again, we will finish the back side of the notes the next day, but for right now, I just want to make sure that we understand when you have variables on both sides and constants on both sides, how to move the variable over, then how to move the constant over, and then how to solve by getting rid of the coefficient. Are there any questions?
Would you be able to do the check on story problems?
Yes, you can. It doesn't work out as great because if your equation is wrong, you might check it and it might say it's correct, but if your equation is wrong, then it's going to be the wrong answer. But you can still at least check to see, did I solve it correctly? Does that make sense? Yeah, good. Okay. And honestly, on your test, there's only one story problem for the whole thing. So, any other questions? Good question. Okay.